This conference will now be recorded.
Last class, we just had an introduction to the WAN evolution, basically, how the WAN has to be configured. So we saw a legacy method. Then we discussed on IWAN, intelligent WAN. That's an excellent concept. And IWAN, I said there's a book that you can read. In that book, 1 or 2 chapters are dedicated on WAS. So if you are interested to read more on WAS, that book has I think 2 to 3 chapters on that, how it can be used in IWAN and how it can be optimized. And now it is integrated with SD-WAN as well. So there is 2 ways. One is app QoE, what Salva was saying. As well, there is an option to integrate the WAS controller with vManage. So you can integrate them. So from vManage, you will be able to have WAS control. So that integration is also available. Or the other best way you can use is app QoE. You can use that. So if you're interested more on that, just go ahead with IWAN book. You can get few details from there. All right, next we need to discuss or continue with the SD-WAN architecture. As I mentioned in the last class, it's basically old wine in a new bottle. The techniques are the same. All the best techniques what is being used has been put it in a simplified way. That is what has been the SD-WAN automation. So if we are now talking about SD-WAN architecture, let's first see the components involved in SD-WAN, and then we can talk about.
Yes. John, are you sharing your screen? I'm so sorry to interrupt you. I cannot see your screen. I mean, I do see
screen
just
is right now the yellow background.
Okay, yellow. Okay. Sorry about that. Please go ahead.
So let us first see the SD-WAN components which are used in Cisco. And then we will discuss what each component does, what is the job of the component. We will discuss theoretically and then we will try bringing in the lab. So here is one sample topology. We will do a similar one, something like this. Now here it is to understand the components only. So if you're looking at the Cisco SD-WAN component, there are controllers. These are the controllers that you see. There are 3 controllers in Cisco SD-WAN. One called as vManage, the other one is called vBond, and then we have the vSmart. 3 controllers. We'll talk more about it, but that's the important part first. Controllers are required. And then you have the usual sites, maybe the data center, headquarters, or branches, or whatever the sites you have. On each sites, internally, whatever component you place, you have your firewalls, you have your LAN, you have your routers, whatever it is. But there would be one device or maybe more than one device which is related to SD-WAN. The one that you are seeing here, this is known as WAN edge device, we call it. WAN edge device. So every site should have a WAN edge device and controllers. That's the component, that's it. You have the controllers and you have the WAN edge devices. So when we say SD-WAN, it is all about the edge device configuration. Internally, you need to be managing. Internally, whatever you want, you manage as usual that you do it. CLI automation, whatever you are doing. Controllers don't have visibility there. The controllers will have visibility only to the WAN edge device. Whatever on the WAN edge devices you want to configure, that is possible from controllers. Anything inside SD-WAN does not have the visibility. But there are other controllers, there are other options, SDA is there. Then there are integration, ACI and SD-WAN integration. Lot of integrations are there. But as we are sticking on to purely on SD-WAN, if it is on SD-WAN, the logic will be you can manage only WAN edge devices, nothing else here. So these are the components that we see. Let me first talk about the WAN edge device. So we have the WAN edge device here. Let's talk about that first. The WAN edge devices, as I probably mentioned in my last class, Cisco acquired Viptela. So today, whatever Cisco SD-WAN we say, it's a Viptela's SD-WAN. The idea is completely on SD-WAN. Cisco Viptela SD-WAN idea. So if you see certain informations or certain configurations are little different than Cisco's standard way. Cisco has its own standard always. Mostly they maintain the standard. But here, if you see, the standards will be different. Like for an example, in SD-WAN, we call VPN, which is equivalent to VRF. Whatever VPN configuration we do on an SD-WAN, it's basically the VRF in Cisco. So what you are going to see is basically an idea of Viptela. So initially when Viptela came up with this, they had WAN edge devices, physical and software-based router. So they had physical device, and that physical device we had called Viptela, V-Edge 100, 200, so on. Different models are available. Physical device. Now, in case you want a virtual router, a software router for a cloud purpose, yes, there are software routers in Viptela, which we call it as Viptela V-Edge Cloud, we call it. So there's a V-Edge Cloud, which I'm using. If you want to make a lab, you should be using the V-Edge Cloud, which is possible on your EVE-NG or GNS. GNS has some challenges. EVE-NG is better, so I prefer go with EVE-NG rather than GNS. And yeah, another tip here, in case you don't have a system which can do this lab, at least 32 GB is recommended. You need to have a system which is having 32 GB RAM at least. In case if you don't have an alternate suggestion, anyways, Netmetric Lab you can access. They have limited hours. But in case if you want to do something by your own, you can always go to Google Cloud. In Google Cloud, you can have a free account of $300 free worth. They give you the service. So you can get a server there, install EVE-NG and practice SD-WAN on Google Cloud as well. It will be a bit slow, but again, it depends on which location you are. What I tried or experienced from Bangalore was a bit slow, but probably from wherever location you are, maybe it could be a little better. So give it a try, $300 worth free service, you can get it if you don't have a system which is of 32 GB capability. So on this, you can install V-Edge Cloud. As you are seeing, these are all the V-Edge Cloud routers here, right here. These are all the V-Edge Cloud routers. When Cisco acquired, Cisco started selling the same, but again, you know, Cisco customer base, they are all using Cisco routers. Now there is a question, should the customer upgrade? If a Cisco customer is looking at SD-WAN, you are supposed to upgrade or change your device. So Cisco started working on the software. Whatever the software was running on this Viptela, they tried bringing in the same features, same functionality into their products. And they were able to do it in iOS XE. So they call that as iOS XE SD-WAN. Not just iOS XE, remember, you have to use a software called iOS XE SD-WAN, and Cisco came up with this software on routers, ISR routers, ASR routers, and now they have come out with the Cat 8000 edge devices, CSR routers, cloud-based software routers. All these devices today support SD-WAN. So the customers who were using Cisco devices and they wanted to get into SD-WAN, the easiest way was upgrading the software. change your software from whatever you have to iOS XE SD-WAN, and you can have SD-WAN on Cisco products. So that slowly migrations happened, and today, yes, today everything is available. I'm talking about those days when initially the Viptela was acquired. So then all these issues were there, and I have seen the progress. I have working from past version 17, the initial version when Cisco took over. Cisco started with somewhere 18. So somewhere 17, 18 Cisco acquired. So I've been using them from quite some time. So I've seen a lot of changes happening, and today, as we discussed in the last class, they have added a lot of stuffs in SD-WAN, security related, cloud services, lot of things. And looks like they will keep adding many more things in future. So to give you an experience on iOS router, Cisco router, I have a CSR router here. So this is the CSR router, which is iOS XE SD-WAN. So we can see how this works. It's all the same. It's going to be all the same, nothing different, because they're all going to be managed from vManage. It will remain the same. Only the initial CLI will slightly change. That's it. Right. So these are the Vantage devices. So if you are planning for an SD-WAN, these are all the capable or the right products that you can use them as your Vantage device. Any question, anything? Okay, no question. Let's get into the controller. We will talk about the first controller that we have, vManage. All controllers in SD-WAN Cisco, they are virtual or software based. You don't have any physical component here. Get the image, and you can install this on cloud, or you can install it on-prem on any server. You have a server on-prem, data center or headquarters, wherever. Probably you have VMware, the most popular, or you can use KVMs. You can install this vManage and utilize them as the controller. So on-cloud installation or on-prem is possible. VMware or KVM. And this is the controller which is going to be a slightly high resource. This vManage is the one, the latest that I saw was version 20. And in the version 20, I saw that it needs 32 GB RAM. 32 GB RAM it needs. But again, you can utilize as per the enterprise infrastructure certification. If you see, the version is 18.4 actually. And for 18.4, you can reduce this. This comes with, I believe, if I remember exactly, 24 GB RAM in version 18.4. But in EVE-NG, you can reduce this to 16 GB RAM. On a lab environment, while you are configuring, installing it, just make it 16 GB so that you can handle it on your machine. So 16 GB I have seen working on a lab environment, not an issue. 32 GB, what I said is for version 20. I have not tried reducing it, so I'm not sure. But again, if you are trying version 20, probably try 24 GB or so. It should work. Check out, I have not tested on changing the RAM size on a latest version. I have used 32 GB itself. And the CPUs, I exactly don't remember, but yes, there are some virtual CPU requirements, around 8 probably. If I recollect, up to 8 virtual CPUs you need it. That's fine. You can manage it with 2, 3. The memory part is the one that you have to take care of. So that's your hardware requirement. Hard disk, yes, you need an hard disk. I'll come to it during the installation. I'll show you a few things. Hard disk, in case of a vManage, it comes with an hard drive. The image comes with an hard drive of at about 20 GB, plus or minus. I saw it about, in the beginning, I saw 19 GB, and it was IDE. In version 20, I saw it is at about like 20 plus GB, and it is SCSI. So please check out which version you are using. Once this vManage image has been uploaded into the VMware, you can observe their hardwares. So it comes by default around 20 GB. Latest ones are SCSI. If you are using version 18, definitely it is IDE. And on this, you are supposed to add one extra hard drive, and that should be 100 GB. But again, not to worry. When you're working on VMware, there is this option called thin. It will allocate an 100 GB drive to the machine, like the value. It says the machine, the volume is 100 GB, but the occupied volume will be based on whatever storage you do. So we call it as thin, we call it. So it's not going to dedicatedly give 100 GB to it. It will just create a volume of 100 GB, but the space, when you use this, slowly the space gets occupied. But on a lab environment, it's not going to be a huge configuration which is going to happen. But you need an extra hard drive. 100 GB is what Cisco recommends. I have seen some students while practicing, they have created 50 GB, 60 GB, and they have tried utilizing it. Cisco's recommendation, minimum, you need to add 100 GB. This will be used as your storage. This drive will be used as the storage drive, where all your configurations, where all your logs, all those informations can be stored. So you need to be adding an extra hard drive to it. So that's your vManage controller. These are the specifications. And NIC card, you need minimum one NIC card. You can make it two, one for control, one for management. I'm going to discuss that now. At most maximum, you can go as 3 NIC cards. Right? Minimum one. If you can work on one on your lab environment, absolutely fine. One NIC card will do the control as well as it will do management. If you want to dedicatedly have one NIC card for control, one NIC card for management, fine. Third NIC card is needed when you create a cluster. If in case you are looking at the high availability in vManage, say I want high availability, what if one fails? Plus, I have a big SD-WAN installation. I want to share the job. I want one vManage to do some job. I want another vManage to do another job. So in that case, Cisco recommends a cluster of 3. A cluster of 3. So you can have 3 vManage installed and make a cluster out of it. And to form a cluster, the third NIC card will be utilized. To form a cluster and synchronize between them, we are using the third NIC card. So if you are not having a cluster, if you are just having a single vManage, then you don't need a third NIC card. You can have just 2 NIC cards, or 1 NIC card is also fine. In a real-time implementation, definitely you should have a cluster of vManage recommended. Lab environment 1 is fine. And the best part, these are the software based. In VMware, you have a lot of options to take a backup, image backup. In case something goes wrong, you can quickly recover it very fast. And vManage, when it goes down, your SD-WAN would not fail. Your SD-WAN will continue to work. Reason, your vManage is responsible only for management. It is responsible only for management purpose. vManage can manage the entire SD-WAN, pushing the configurations, all those things. If it fails, you may not be able to manage your SD-WAN, but your SD-WAN will continue to work. So it's absolutely fine. You say, I have one vManage and it has failed, no issues. You try to recover it as soon as possible by using the image backup that you have taken. Right, so these are some specifications of vManage. Hardware, what are the requirements of the virtual machine? and the high availability cluster of 3, how many NIC cards, why they are used. I try to put it across. Any questions related, let me. Okay. vManage is used for centralized management. Centralized management. Once your SD-WAN is completely deployed, initially while deploying, you might have to use CLI. But there are times that you don't have to do even a CLI. There are times we call that as ZTP, or we have something called, Cisco calls it as plug and play, they call it. If you're trying to do this, probably you don't need any CLI. Just connect the device, turn it on. Your Vantage device I'm talking about, the controllers need some management. The Vantage device, you just turn them on, they automatically get connected, they discover the controllers, they automatically get the configuration, they come up. That is one way. The other way is you can do some basic CLI configurations. We call them as a bootstrap configuration, we call them. You can do a basic bootstrap configuration, turn on the device, let it get connected, and after that, everything will be managed by vManage. Centralized management. If you ask me, is it not possible by CLI? Very much possible by CLI. Would you like to manage by CLI every device individually? It is possible. But that's not the solution, right? We are talking about SD-WAN. Software defined. When you say that, we are looking at automation, we are looking at centralized management. Easy. So if you end up using CLI, then there is no point of you saying that you are using an SD-WAN. You better go with IWAN. But it is possible. There is an option that you can configure it by CLI. So vManage gives you centralized management. All the configurations can be done on vManage and pushed to the respective device. As well, monitoring. You want to do some monitoring, vManage has some good options for monitoring centralized. Every site, every Vantage device, informations can be collected by vManage in forms of events, in the form of logs, in the form of alerts, etc. So we can see what's happening on each site, what is the latency, what is the delay, what is the packet loss, what failure happened. Most of these events can be seen. But there are customers I have come across who say, no, we are not happy with this, we want some more. We want more informations related to our site. So Cisco says, okay, we have a little detailed, if you want, vAnalytics. And there is another one, 1000 eyes. But these are the paid services. You want these services additionally where you can get detailed analysis about your SD-WAN. You can go with vAnalytics or you can go with 1000 eyes. If not, there is built-in monitoring, but as I said, there are some customers who are looking beyond that. So monitoring is again an option in vManage centralized. And then the other option that you can do from vManage is software upgrade. If you are planning to upgrade your SD-WAN, centralized again. So it's like a repository. On vManage, you can upload all the images which are available, needed, and then you can plan your upgradation from vManage. So from vManage, every SD-WAN component can be upgraded. So all these are the capabilities of vManage. Configuration, monitoring, software upgrade, all these capabilities will come by using vManage. So it's a management plane. It has nothing to do with control, nothing to do with data. No control plane functions, no data plane functions. Only management plane functions will come on vManage. Any questions now on vManage? Okay. The next one is important. The next one that I'm going to discuss is about vSmart. vSmart is considered the brain of SD-WAN. Cisco Viptela SD-WAN, the brain is vSmart. vSmart does a lot of jobs for us. In just simple words, vSmart is responsible for control plane activities. All your routing decisions and security policies are handled by vSmart. Routing policies, security policies, they are coming from your vSmart. That's a simple one-line statement if we have to understand what is a vSmart. We will discuss more now. A lot of things to understand here. This is important. This is going to play a crucial part of an SD-WAN for us to understand how really it works, what is happening really in an SD-WAN. Again, a vSmart is virtual. It's not a physical component. And this can be installed on cloud, on-prem, and it is always recommended for high availability resilience. Make sure to have multiple vSmarts. On a lab environment, one vSmart is fine. But when you go real world, one vSmart is definitely not recommended because it's a control plane brain. If vSmart fails, your entire network will go down. This is something I believe is not Cisco's design. Cisco never designs their network in this way. If you look at ACI, the Cisco's initial SDN concept, they made sure that the management is centralized using APIC controllers. But the control plane and data plane is distributed control plane and data plane. They are decoupled. Every switch in ACI, spine, leaf, whatever we say, they do control plane and data plane function. If APIC controller fails, your spine and leaf can continue to work. If one of the leaf fails, that's the loss of those devices who are connecting to that leaf, but the rest of your network will continue to work. But here, if you see the Viptela's logic, what they did, they used centralized control plane. If vSmart fails, complete SD-WAN will go down. It's a centralized control plane. You are getting all the control informations from vSmart. It's good. See, there are two ways to see. Cisco's techniques are different. What Viptela did technique is excellent as we go further, but if you want to use this, high availability is very, very important. Never design an SD-WAN with one vSmart. Lab environment, we are going to use one vSmart. It's about learning how to configure, what it is happening, what is the policy. We are learning. But when it comes to production, you should use minimum 2. You can use 3, 4, 5, multiple locations. Like you have too many sites, they are spread across multiple locations. And you keep vSmart in one fixed location, which is not good. You probably have sites in Bangalore, you have it in US, you have it in UK, blah, blah, blah. You have so many places. And you have all the controllers placed in the US. That's not right. So you need to design your SD-WAN, especially the vSmart, spread it across. Keep few vSmarts in some location. So these devices can access the closest vSmart. Then you can place vSmart here, so you can have closest access, something like that. If it fails, they can automatically connect to this guy. So all that planning is available. You should be utilizing them because it's a centralized control plane. It is not a distributed control plane. If a failure occurs on vSmart, everything is going to fail. Okay, hope you understand that. vSmart is again not a high resource consuming product. vSmart, you can have like 4 virtual CPUs, and what I observed in multiple versions, 2 GB RAM. Just 2 GB RAM, 4 virtual CPUs, hard drive, I believe it is around 20 GB or so. I don't exactly recollect. It was not very important to see the hard drive on vSmart because they don't store any much information. vManage is the one who stores a lot of information, especially the monitoring part. But what I observed was the CPU and RAM, it's around 2 GB RAM and 4 virtual CPUs that you need. And I have changed these virtual CPUs to 1 as well sometimes. Sometimes the CPU goes very high, so I change it. And it works fine. For a lab environment, it is fine. And it comes with 2 NIC cards. One for control, one for management. Okay. So we'll discuss more. You'll understand when I say control management. vSmart is used for control plane. So you might be thinking, what is this management now? Individual device management might be needed. So you'll get the management interface extra. We'll discuss. You'll get an overall picture now. So install vSmart wherever it is and make sure all controllers are reachable to every site. Probably I'm going to connect it to internet. Every controller, vManage, vSmart, vBond should be reachable to every site. I'm just taking an example of vSmart right here. So vSmart, I have installed it wherever it is, making sure that it has access to internet, and every site is going to have access to vSmart. So let's take one example of a site now. So imagine I have site 1, and in this site I have one Vantage device, whatever it is, whether it is Viptella's VH device, or is it Cisco's CSR router, ISR router, ASR router, whatever the devices, techniques are the same. So I have site 1 installed with one Vantage device, and for simplicity, let's say we are connecting to one LAN behind here, and then this is getting connected to the internet. Here we need to learn few things now. When you are using this Vantage device, the basic requirements are the interface which is connecting to your network, transport network. So your internet is right now the transport network or an underlay network. Now recollect IWAN. Exactly the IWAN techniques are going to come now. To connect to this, you should always use a dedicated VRF. And in SD-WAN Viptela, they don't call it as VRF, they call it as VPN. You need to be creating a separate VPN to connect your transport network, internet, MPLS, Metro Ethernet, whatever you have it. In Cisco, it is known as VRF, and especially these VRFs are known as FVRF, front door VRF. And your LAN behind that you have, your corporate network, should be in a separate VRF or a separate VPN. And in case if you have a management interface and if you are planning, it will be there. In case if you want to use it, sometimes maybe you don't want to use it. If in case you are using it, that management interface should be in a separate VPN. So in Viptela SD-WAN, the VPN is nothing but VRF. And the VPNs are always here by number, not by name. So you create a VPN 0 dedicatedly for transport. So it has to be VPN 0 here. VPN 1 to 511 is called service VPN. That is here. Your corporate network, LAN, wired, wireless, guest networks, whatever you have, they are called service VPNs. So you can number them between 1 to 511. 512 is a management VPN. Earlier, I remember only 512 VPNs were available. Then they went ahead, extended it. So they said 513 to 65, 535. They again said you can use them as your service VPN. So you have one transport VPN dedicated, one service VPN, sorry, one management VPN, rest all service VPNs. So VPN 0, VPN 1, VPN 512. Same way, if you have another site here, you have site 2, and this site 2 is connecting to internet and the LAN. So you need to probably a management interface. So you need to be creating VPN 0 here, VPN 1 here. If you recollect the MPLS logic, where we used VRFs, we use VRF on a PE router, imagine VRF A, and on another PE router, we use VRF C. It's absolutely your choice. The VRF need not match. And here we used a logic of route targets and RD, saying that, okay, the routes of this VRF A should be imported in VRF C this side. So which routes will enter which VRF was decided by route targets. Same technique is used even here. As I said, SD-WAN is using all the best techniques. So here is an example of the MPLS technique. But instead of using the RD, RT and complicating things, they came out with the logic, same VPN. When the routes of VPN 1 arrive here, it will be imported inside VPN 1 only. By chance, if you configure VPN 2 here, they are in two different VPNs, they are in two different VRFs, they cannot communicate to each other. If you want to communicate, you have to do VRF leaking concept. You need to do VPN leaking here, if in case you want to communicate between 1 and 2 then. So that's the technique they made it to simplify it, automate it. They made it this simple. If the VPNs are same, whatever the routes will come will automatically get imported into it. You don't have to do any configuration for it. But in case if there are two different VPNs, then you need to create a policy for it. And you need to mention which VPN route should be imported to which VPN. So you need to be involved then. So that's the logic that they have tried using here. So keep in mind to use same VPN so that the routes can be imported and exported. So technique of MPLS. Simple. Any questions? All right. And here VPN 512 for management. So that's the VPN part that you need to do not only in your WAN edge device, even in the controllers. When you talk about the controllers that we have, vManage, vSmart, vBond, these controllers will also require VPN, but they support only two VPNs, VPN 0 or VPN 512. No service VPNs are allowed. Obvious. There is no data plane in that. There are no data planes. They are controllers. So they will have VPN 0 or VPN 512. Like vSmart, the one who's connecting to internet is going to be VPN 0. So they can get connected to other WAN edge devices and they can do the communication whatever required. And then you can have a separate interface here configured as VPN 512 for your management purpose. You want to SSH to it, you want to do some configuration maintenance or something like that, you have VPN 512. That's it. You cannot have more than that. So controllers come with two VPNs, 0 and 512 that you can configure. WAN edge devices will have service VPN extra. So that's how you should begin the story. So when you start with SD-WAN, This is what you need to be doing, the basic configuration that VPNs have to be managed. Any questions? Let me know. Okay, I guess no questions. Now let me tell you, what is the basic bootstrap configuration that you need to do on your Vantage device? Vantage or even controllers. Let me write it here. The basic bootstrap configuration that you need, whether it is controller or whether it is the Vantage, you need to be configuring certain system parameters, we call it. And those system parameters are, you need to configure organization name, mandatory. This acts like one of the parameter used to authenticate or authorize the device. When the device get connected to each other, when they try connecting and communicating, they verify the organization name. So this organization name should be same on all devices, very important. And this name is something which is registered in Cisco Smart Account. You need Cisco Smart Account, you need a file, we call it as a serial file. That's the license part of SD-WAN. I'll come to it more little later. When you register for SD-WAN in Cisco Smart Account, you need to be giving your organization name there. Basis on it, you will get a serial file. I will talk more about it. So make sure the organization name is matching on all your devices. So that's something mandatory that you need to configure. And after that, you need to configure a site ID, site 1, site 2, including the controller. Controllers will be in one site. So some number, that doesn't matter. A site ID basically gives, like a pod, a collection of devices in one location. Like imagine if you have, for example, site 2 with 2 Vantage devices connecting to internet. You might have one device here, Vantage 1, Vantage 2, for redundancy's sake. Between these two devices, would you like to create a VPN tunnel? Normally, no. There's an option. If you want, you can create tunnel. There is an option in Cisco. Normally, no. You are within the same site. You don't have to create a VPN tunnel between each other. So how does my system understand it? Site ID. By site ID, it understands that these two devices are in the same location. So between them, VPN is not needed. So site ID basically gives a location of the device. Maybe there's one device, maybe there's more than one device. So you need to configure a site ID. And then comes system IP. Something similar to our router ID. Router ID we configure it per routing protocol like OSPF, EIGRP, BGP. But in SD-WAN, you need to configure an ID for the entire device. So they call that as a system IP, they call it. I'm just giving a reference like it's a router ID, but not for a protocol. It is for your entire system. It's a system IP. And when you configure a system IP, automatically your device will create a loopback interface for that IP address. Okay, hope you're getting it. When you configure system IP 111, for example. And when you check show interface, you can see one loopback automatically coming up with that IP address. So it automatically creates a loopback with the IP that you mentioned. System IP, very important, mandate. And then you need vBond IP. vBond IP. Every device in SD-WAN will have the contact information of vBond only. Like these guys, when they come up, they never know who's the vSmart, who's the vManage. What they know is vBond. We'll discuss more about vBond next, but vBond is the one who's going to connect these guys. We'll see that later, but that's mandatory information. You need organization name, site ID, system IP, vBond IP, and one last system IP. Again, like a router ID, they need not be a reachable IP. Just give some number, no problem. It should be like an IP, but they are not a reachable IPs. Fine. One more, lab environment, not mandatory. In real world, probably you can think of NTP. Because all these guys are going to bring up a kind of control plane security using TLS or SSL. For that, certificates are used. Date and time synchronization is very important. So in real time, have an NTP, make sure all your devices are synchronized. In lab environment, your EVE-NG automatically picks up the clock from your VMware, and your VMware picks up the clock from your laptop. So the clocks will be synchronized on all your devices on the lab environment. In real time, think of using an NTP. Rest, nothing required. These are the basic Bootstrap system level configuration you need to begin. And then the next one, VPN 0. Under VPN 0, one interface has to be configured minimum, like this guy I'm talking about. Go to this interface, whatever the interface is here, put this guy into VPN 0, like how you do VRF, add a member into VRF, exactly. Put this interface into VPN 0 and do the necessary configuration so that you have your underlay running. Like configure the IP. Imagine the IP address 3.3.3. And then to access internet, whatever the protocol, probably a default route. You can configure a default route so that you have access to your transport network, and through that you should be able to reach other devices in SD-WAN. That basic VPN 0 setting has to be done. So this is something basic that you will be needing to start off your SD-WAN devices. Few more are there, but just I kept the basic that you need as of now. As of now, for us to understand, this is what we need. And the underlay configuration, you can run default route, BGP, OSPF, anything. Commonly, it's BGP or default route. So they have the facility of all protocols. So choice is yours. I can simple here by saying default route. So these are the basic settings needed on a device in SD-WAN, whether it is a controller, whether it is a VANage, very common, very similar. Any questions now here? Any confusion on anything? Let me know. Okay, all looks fine. As you do this basic configuration, your VANage device will automatically pick up an option called as TLOC. It automatically picks up something called as TLOC, transport locator it is called as. Once you do these basic things, they get this value. Recollect in EIGRP OTP, I gave you a little basic introduction to Lisp. In Lisp, they introduce the logic of separating the IP into two parts, identity and RLOC. If you want to reach any destination, you should be knowing the RLOC, and the destination that you are trying to reach is the end node identity there. Simple words, GRE tunnel. In GRE, you are going to see inner IP header, then GRE header, and then you see the new IP header. The inner IP headers are the actual end nodes, your source and destination actual. And the new IP header is basically the one that you have mentioned as tunnel source and tunnel destination. RLOC is something here. RLOC is that new IP header which gives you the underlay network or the transport network source and destination. And behind it, whatever service VPN you are seeing, they are right here. That is end node identity. That is Lisp, like GRE tunnels. But Lisp has some automation. We have controller, we have registrations, auto discoveries. It has some automations there. Same logic is used in SD-WAN, and they called it as TLOC. They called it. Instead of RLOC, it's a TLOC. Transport locators, they are known as TLOC. So again, you see, they are using the techniques, which is the proven good techniques available in networking. They have used those techniques. So you are seeing the next one, TLOC. So it automatically picks up a TLOC. And the TLOC in this case is made of system IP. It is made up of color and encapsulation. 3 parts make TLOC. Now, just to get few things, let's say, for example, the IP here is 222, the IP here is 111 for an example. And the system IP I configure, I'll just write it as sys IP. Let's make it like 10, 10, 10. And let's configure here as sys IP 20, 20, 20. You need on vSmart, but not important, ignore. There's no data plane. TLOCs are used for data plane. Just ignore it. So you'll have 10, 10, 10 here, 20, 20, 20 here. So on this managed device, the TLOC is going to be 10, 10, 10 color. In IWAN, when Cisco made this IWAN, and when they came up with the logic of PFR, they wanted to identify each circuit, each WAN circuit separately, so that the measurements are happening based on it. So in IWAN, each WAN circuit was named. We call that as path name, we call it. In virtualized SD-WAN, they called it as color. The WAN circuit that you are connecting here, you need to identify it, which will be useful later on when it comes to creating a VPN tunnel, when it comes to AAR, application aware routing. These information will become very, very useful. It's like a tag. If you don't understand the color, understand it like a tag. You're just tagging the WAN circuit. You're just identifying your WAN circuit for later use. In SD-WAN, it's called color. There are some predefined colors available like MPLS, BIS Internet, public internet, then there is gold, silver, so many other colors names are there, and private custom names are also available. You can choose any you want. In our case, let's call it as BIS Internet. And recommended, please use the same name on the other side. It will be useful for us. You can give any name, that doesn't matter. You can still manage it. But it's good if you can give the same name for the same WAN circuits used. All the internet links on all sides, if it can be named as business internet or public internet, or choice is yours, you give some name. But make sure you give same name. It will be useful. As I said, you can give random any name, still they can work, but When time comes to optimize, times comes to make some policy decisions, when the colors are different, how will you make a decision? You want to make a policy decision, one kind of, PBR or some kind of policy you want to create based on the circuits connecting to internet. In my case, it's very easy. I say match the color called this internet. If it matches, do this. If you have different names, imagine your job is going to be tough. So please maintain same name for those WAN circuits connecting to that common network like internet. If you have MPLS, give a different name. If you have one more service provider, give a different name. So that's the color which comes here. So it's this internet right now. Encapsulation. Site to site. What kind of tunnel will come up? Obviously IPsec, but there's an option of GRE as well. But obviously it's going to be an IPsec tunnel which is going to come up between two WAN edge devices. So it's going to be IPsec. So the key log is going to be this. 10.10.10 this internet IPsec is the T log. Same way this guy creates. My T log is 20.20.20 this internet, and the encapsulation is IPsec. They automatically create this called as T log. Any question on this? Let me know. You can connect dots as we further go. You will see the use of it. If the question is why it is used, we are coming to it. How the T log is getting derived, if you have a question, I can answer. So as we further go, you will automatically see that these gets connected. You will understand where these things are coming. Now questions, let's take a break here, 5 minutes break. After break, we will continue. We will discuss next what is going to happen, how these guys are going to connect, and how they exchange the information. A lot of things to understand. This is an important part. This is the brain of the SD-WAN. So let's continue after 5 minutes. Hello everyone, I'm back. Hope you're all there. Let's resume. Any questions before we resume? Okay. So these were the few details that we discussed: VPN, the bootstrap configurations, and then the T-lock which comes up automatically. So these are some important things which happen in SD-WAN. Further, continuing, I think this will junk up now. I will go ahead, clear this and rewrite few things. So we'll just keep vSmart. We'll have the internet part here. And this is connecting to one Vantage device here. This will be site 1. And then another here, site 2. And by now you know VPN 0, some VPN behind. Let me write it, VPN 1, let's say VPN 0 here, VPN 0 here, VPN 1 here. And they have got the T-lock. Let me just write down the T-lock. So it's got the T-lock as 10, 10, 10. I'll just write it to make it easy. There's a color called gold. I will use that here just to keep it easy, and then IPsec. Similarly, here we have a T-lock. The T-lock is 20, 20, 20, gold, and IPsec. And this IP, we assumed it to be 2.2.2. This IP, we assumed it to be 333, and we have done a default route. vSmart IP all, we will ignore right now here, that's fine. So as and when this Vantage device comes in and makes a contact with vSmart, it recognizes the vSmart. They basically authenticate and authorize each other. So between two devices, whether it is controller to controller, Vantage to controller, any combination you take, between two devices, there is always a TLS, or the popularly known SSL handshake, which happens. So here certificate becomes mandatory. You need certificates. We will see in the lab how certificates can be installed, how we can utilize it, but certificates become mandatory here, and they authorize and connect each other, authenticate each other. Looking at the certificate, they perform an handshake. Not only certificate, that organization name we check whether your organization name is matching, certificate details, who issued the certificate, the basic SSL logic. If you know, the SSL handshake that you know happens between two devices. It could be between two controllers, or it can be between Vantage device to a controller. They perform this. And we say it establishes a control connection, we call it. There is a secure control connection established between two devices using TLS logic. So any communication happening between these devices are safe. This is what they call zero trust architecture. There is a control plane security, there is a data plane security. Your data are safe, your control plane is also safe. So as and when this Vantage 1 device comes up, it is going to form a tunnel with vSmart using TLS. By default, it is DTLS. By default, it is DTLS, which is UDP based. TLS is TCP based. A UDP is recommended. Cisco says that the operations are going to be simple in UDP. But still, if you want TCP features, reliable features, you have an option to change it to TLS. default it comes as DTLS. So it establishes a DTLS connection with the vSmart. Not only this WAN edge, the other WAN edge also establishes a DTLS tunnel. Okay, hope that's clear. Between each controller, vManage to vSmart, vSmart to vBond, vBond to vManage, whatever the combinations you say, there is a control plane security. Control connections come up through this SSL. Okay, any questions? Once this connection is made, inside this connection securely, they bring up overlay routing now. Overlay routing. Remember in IWAN we discussed, you will have an underlay routing like we did here, right here. We have internet transport network. We have an underlay routing, BGP or internet default route, whatever. We do that one. And over that, we bring up an overlay network in IWAN. Just comparing now, in IWAN, we bring up an overlay network called DMVPN. Under that, we run an overlay routing like EIGRP. Whereas in SD-WAN, instead of DMVPN, they are using DTLS. DMVPN in IWAN was protecting control and data. EIGRP protocol was protected by DMVPN, your data was also protected by it. But in SD-WAN, control plane protection is happening by DTLS. So DTLS comes up, which is creating an overlay network between the controller and the WAN edge device. And then a routing protocol comes up. Proprietary to Viptela, which is Cisco now, a proprietary protocol designed called OMP, Overlay Management Protocol. And this is very close to IBGP. OMP, I think they have a patent. They have applied for an RFC. I'm not sure now. A few years back, I had checked all these things. So OMP is a proprietary protocol by Viptela, very close to IBGP, and OMP works on TCP port 17900. And as per this, your vSmart is the route reflector using OMP, and your WAN edge devices are all going to be route reflector clients. Like if you recollect in BGP, we discussed route reflector can be inline or non-inline, meaning the data can flow through the route reflector inline, or you can have a separate path for data flow and route reflector will handle only the control plane. Exactly the same here. This vSmart is running OMP for control plane purpose. Data will never come to us. Our job is to synchronize the routing between these two WAN edge devices. So please recollect the BGP logic. If you have multiple routers, make one as route reflector, rest are all the clients. So the BGP will update through this route reflector, but data can flow directly between these two devices. You can have some link between them, you can have some OSPF between them, and data can flow directly. Same logic, data will flow site 1 to site 2 directly through internet using this underlay, using the VPN logic. But the control plane routing happens something like this. So in SD-WAN, between two WAN edge devices, there is no direct routing. There is no direct routing. We don't do any routing between site 1 and site 2 directly. It happens through vSmart. This is what initially I said, that vSmarts are going to be centralized control plane. If they fail, every site will lose connectivity. They will lose the routing informations. Then gone. So that's the point that I was trying to mention. So make sure to have more than one vSmart, 2 route reflectors, so that you can have multiple reflections happening and you have redundancy there. So that's the protocol OMP. So using OMP, they are going to form a peer. So I'm just putting another dotted line to represent the OMP session. So we have OMP session inside DTLS. Don't worry about security. There is a DTLS tunnel which has come up already by a certificate, verified, authorized. Inside that OMP has come in. So completely secure, zero trust architecture this is. So similarly, we have the OMP session coming up between this vSmart and this site here, OMP session. And this OMP is responsible to carry TLOC informations, TLOC routes they are called. Like an example I'll put here. Site 1 will now, as it forms an OMP session, immediately it will send the information to vSmart. This is my TLOC. I have a TLOC called 10.10.10 gold IPsec, and that's reachable by a WAN IP that I have called 222. So that's the WAN IP and that's the TLOC that we have created. This information vSmart picks up and will distribute it to all other authorized WAN edge devices. So we inform this guy, there is a site and he has a TLOC and this is the IP for it to reach. So this is the local TLOC and now I have a TLOC of remote and the remote TLOC is 10.10.10 gold and IPsec, and that's reachable by the IP 222, which is a transport underlay through VPN 0, it is reachable. So we get the reachability information and the TLOC information. I'm just putting across site 1 to 2. Please remember, same thing happens between site 2 to 1 as well. I'm not just adding here, that's it. Site 1 will learn. Like this, every site learns all the other remote site TLOC. If you don't want to learn, create a policy and you can deny it. By default, every site TLOC will be exchanged. If you say, I don't want to communicate to this site, block him. Choice is yours. You can block the complete TLOC if you want to. So all those possibilities are there. So this is what your OMP carries. It carries a TLOC first, an information which is very important because TLOC is going to act as the next hop attribute of BGP. TLOCs are the next hop IP attribute of BGP. You can see next, I'm going to tell you that. All right, so this happens. Next, let me change the color. Next, it carries V routes, or it's called OMP routes, service VPN routes. They are referred as V routes or OMP routes. Whatever the service VPN you have here and the network what you have, let's say for example 172.16.0.0, and here you have 192.168.1.0 for example. They exchange this information. And in case if you are using connected networks like you are seeing right now, connected, or you have some static routes, probably you have a router here, then there's a network here, and on a WAN edge device you have created a static route to reach this network, or you have OSPF internal. All these by default get redistributed into OMP. Auto redistribution happens. Automation, SD-WAN. Whatever I'm saying will happen automatically. Theoretically, I'm explaining, taking time. When you implement it in 5 minutes, all these will happen. T-locks are generated, OMP is established, T-lock is exchanged, V-routes are exchanged, IPsec tunnel comes up, ready. 5 minutes, it's all ready. So all these are happening automatically. So your service VPN routes will automatically get redistributed into OMP if they are connected routes, static routes, or OSPF internal routes. Anything else, you have to redistribute. Like you have OSPF external or you have BGP. Now, latest version, they have started supporting EIGRP, Lisp, ISIS, I think, if I recollect, if I remember seeing it. But definitely EIGRP, I remember, Lisp, I remember. They are also available. You have to do a manual redistribution. So they get redistributed and this routes will reach to vSmart. So I inform the vSmart, I have a vRoute called 172.16.0.0 and that's reachable by a T-lock 10.10.10 gold IPsec. That's the next hop IP. So when vSmart receives, by default, he will replicate it to all other sites. If you don't want, you can stop it. You may need some policy saying, no, I don't want the communication blocked then, fine. But by default, vSmart will reflect this to all other sites. So this guy will receive the route and automatically import it on VPN1. These routes were redistributed from VPN1. Here, it will get imported on VPN1 only. So on VPN1, we get this route in the routing table. We will have OMP tables like BGP table as well as RIB table, routing table, and in that you can see 172.16.0.0 is reachable via 10.10.10 gold and IPsec. That's your next hop IP. Recollect MPLS now. In MPLS, this logic we had discussed, what you are seeing here is the global VRF, which were running LDP protocol, OSPF, MPBGP. This is the customer's VRF, customer-facing VRF. And in the customer-facing VRF, we had the destination pointing to the next hop IP reachable in the global VRF. So if you want to reach 172, it's reachable by a T-lock, and that T-lock is in your global table VPN 0, which is pointing to the IP 222. So this is going to be your inner IP header, end node identity, and this one is going to be your outer IP header, which we are going to insert and forward it, which we are finding out through this T-lock. So it's MPLS logic. If you see the MPLS VPN logic, but there they used LDP, MPBGP, a lot of other things. But here they derived the same way in a different technique. Same logic if you are seeing right now. So this way the informations about the service VPNs are exchanged. Is that fine? Any question, anything, let me know. It's not easy. You have to go through again and again. I took months together to understand all these things.
So, John, you said about the automation, right? So, like forming the IPsec tunnel, all jobs in 5 minutes. Who does it actually? Like the REST API call, or how we can understand that?
These are all the predefined tasks which is there on vManage actually. So all these are happening from vManage. So you have the vManage here. So on the vManage, we are adding vSmart, we are adding these devices, they make a contact. And on vManage, there are default templates or policies which are available. And these are pushed to these devices by REST API. If it is a Cisco CSR router, I have seen it, it happens by netconf. So they use RESTconf or they use netconf. This automation is done. So vManage will push these policies to the respective devices, like vSmart. vSmart, you need OMP, you need the concepts of replicating all these informations to all sites. We call it as by default, it is a full mesh policy and ECMP policy. By default, it is a full mesh. Every site will learn everything and they achieve ECMP by default. That policy is being pushed automatically by your vManage. What was your question?
Yeah, and I assume the vSmart basically in a real time we deploy in the data center. And in vSmart, can I enable the service VPN also?
As I said in the beginning, controllers support only two VPNs, 0 and 521.
Right. So in that case, if I want to exchange the data center networks, should I deploy a vEdge extra or
Yes,
how it?
if this is your data center, you will have to be placing one Vantage device here, which connects to the outside world. And here you should be having vManage, vSmart, vBond somewhere here in your data center.
All right. Okay. Got it. Thank you.
Anybody else? Okay. There's a few more things that we need to complete here. IPsec tunnel. Control plane, almost we are there. Now the control data plane has to come up. There should be an IPsec tunnel, an overlay tunnel, so that data can flow through that. So control plane tunnel is different, data plane tunnel is different. So we have one overlay here called DTLS, which is taking care about control plane. You need an IPsec tunnel, which is going to take care of your data plane. So here it goes related to it. Your OMP is also responsible to exchange security keys. What we learned in IPsec VPN, slightly it is going to be different. Just a quick recap. If you remember the IPsec VPN, what we learned, there is IKE v1 negotiation, IKE v1, let us stick to it, phase 1 negotiation, phase 2 negotiation. Between two routers, they negotiate, then they form a tunnel. In SD-WAN, Cisco SD-WAN Viptela logic is slightly different. Here what happens, between two Vantage devices, there is never a negotiation. We never negotiate anything between two Vantage devices. Everything comes from vSmart. Right? So what happens in this SD-WAN is Site 1 Vantage device will automatically create a security key. There's a by default policy pushed by the vManage, which specifies this device to use a cipher suit. There is a cipher suit by default selected by your Vantage device. Using the cipher suit, it defines a key saying, you can use this key to encrypt the data or decrypt the data. This is my key. If you want to send data to me, this is the key that you should be using to encrypt it, and I will be using the same key to decrypt. It is the symmetric key only. But the keys are different. Like this guy, Site 2 says, I'm creating my own security keys. Key number B, the key B is used for my data encryption and decryption. And this guy say, I created a key called A, which will be for my destination data encryption and decryption. And this key is passed on to the vSmart through the DTLS tunnel. So we tell vSmart, these are my keys. tell anybody who wants to reach to me, use this key to encrypt it. And that key is shared to all other sites, saying if you want to reach this particular site, this particular destination, this is the key that you should be using. Same way, key B is also exchanged. There is no negotiation between site 1 and site 2. So that means there is no phase 1 in SD-WAN. If you recollect phase 1 was required to negotiate IPsec parameters securely. Phase 2 is the one which is doing your security keys actually. Here, those security keys are exchanged inside the DTLS through vSmart. Why do you need a phase 1? There is no phase 1 in SD-WAN. It is only the phase 2 IPsec parameters. Keys are generated by each device. They never negotiate as well. In normal VPN, we negotiated. We exchange that quick mode, if you remember 3 messages we have. But here we never exchange it. We say, I have my own keys derived. I will share it with everyone. You use that key to encrypt and send it to me. So there is only IPsec involved. There is no IKE phase 1 involved right here. So that way, the data between these two sites are encrypted. So we say there's an IPsec VPN tunnel then. It's a logical. When you say tunnel, there's nothing there actually. It's just a logical that we analyze it. So by these keys, the data gets encrypted. So if you want to reach 172, we have the TLOC. That TLOC is reachable by 222, and to reach that, we have an IPsec. So encryption happens and the data is sent over. So data flows like this. So we say between these two sites, an IPsec tunnel has been established. Not only IPsec tunnel, per TLOC, they establish BFD as well. Per IPsec tunnel, sorry, per TLOC. So you have one TLOC here, one TLOC, per TLOC, one BFD will come up. IKE V1 phase 1 had another function called DPD, dead peer detection, keep alives. So they keep exchanging a keep alive to understand whether the tunnel is up or down. How about here? How do I know that the site has gone down? I need to break this VPN tunnel. I need to break the data flow. BFD comes up. So BFD in this right now, it does a lot of other functions. I'll come to it a little later. As of now, it is taking care of your keep alive job. So there's a BFD. If the BFD fails, they break the IPsec tunnel immediately. They stop the data flow happening there. So we can find an alternate way. So there is a BFD which comes up. All these are automatic. Everything what I said here happens automatic once you do the basic bootstrap and activate it. They will automatically contact, establish OMP, TLOC routes exchanged, OMP routes exchanged, security keys exchanged, BFD tunnel came up, IPsec tunnel came up, ready for the data flow. 5-10 minutes probably, it's all up. Any question, anything, let me know now. Probably the whole picture we have got. I will add one more WAN circuit for understanding. One more WAN circuit. So usually we recommend 2 WAN circuits, maybe more than 2 if you want, at least 2 for our redundancy. Okay, so let me complete this picture by putting in one more WAN circuit. So we have one more WAN circuit, say MPLS. Choice is yours, whatever you feel, whatever is available at your location, a reliable one, you can choose. So we are taking an example of internet and MPLS. So you'll have the connection to this here, connection here, and it has to be in VPN 0. So 2 transport networks inside VPN 0. 2, 3, 4, choice is yours. And this may have some IP address here. Let us assume the IP that we have is just okay. I'll just take it random 444 and 555 here. Right, so you have one more link, commission it, configure whatever you want, P to C routing, BGP or static routes, whatever you want. Go ahead, commission, and now your site one will create one more TLOC. It says we have one more TLOC. TLOC number 1, TLOC number 2. We have 10, 10, 10, color MPLS, IPsec. Even this guy says, okay, I have 2 TLOCs now. I have 20, 20, 20. I have gold and I have IPsec. And that information is passed on to the other site. We pass on saying that we have gold and we have, I'm writing here just MPLS like this. So we send 2 TLOCs to this guy and the next hop IP will be for this one 444. So here I make a note, okay, 10, 10, 10 is reachable by 222 gold. We have one more, 10, 10, 10 is also reachable by MPLS, IPsec, and the IP here is 444. So you have 2 WAN circuits, there will be 2 TLOCs created. For each WAN circuit, 1 TLOC created. So the color should be unique. You can't give the same color to these 2 interfaces. One should be like gold, another one like MPLS. You can't give both gold. So that information is passed on the other side. And now if you look at here, it would say it's reachable via 10, 10, 10 gold IPsec, 10, 10, 10 MPLS IPsec. So here this provides you now ECMP by default. So when you try to reach 172, it says there are 2 paths. Okay, let's choose one, maybe gold, maybe MPLS. If it is MPLS, we check here. Through MPLS, what's the next stop? Okay, let's encapsulate it by 444, push it out, encrypt it and push it out. ECMP comes by default. If you don't want ECMP, you want primary, secondary, choice is yours. I'll show you while configuring different policies. Hub and spoke policy, ECMP policy, primary secondary policy, AAR policy, how to implement it. So this way, when you have multiple WAN circuits, you get extra TLOCs and that TLOC information is exchanged. So every destination will have multiple TLOC as next hop IP. So when data flows, they do ECMP between them. Simple. I think now you have got the complete picture. You can connect the dots now. Only the vBond is left. It has nothing to do with whatever the process we discussed right now. So just I'll hold here for a minute, think over. If you have any question on how this control plane routing and security works, let me know. Okay, I guess no questions. Seems it's all fine. As I said, please go through again, go through the recording at your own pace and try understanding each piece. Because when you do lab, all these will happen automatic. You don't have to really bother about them. Just bring up the WAN site, configure the bootstrap configuration, activate it, sit back, relax. All these will happen. So it's going to be like a magic. But if you want to troubleshoot, you want to understand, these are very important. So implementations are going to be very high level information. It's very easy. It is going to be. Right. Let's get into a vBond, the last part that we have. Let us get into that vBond. Let me just take a screenshot of this. Might be useful sometime to refer it. Now comes the last controller that we have called vBond, known as orchestrator. I would like to call him as a broker. That's the statement that we use, broker. It basically like now connects two parties. Somebody is looking for a house, so you have a broker who does this job, connects them. Once they are connected, it's between you guys, landlord and the tenant. You guys talk to each other, you maintain whatever the relationship it is. And probably you want to vacate, look for a new guy, again contact the broker. Broker says, okay, fine, I'll find you another one. vBond is exactly the same. He is the orchestrator. That's the job he's going to do basically. So imagine a Vantage device is coming in. If you recollect, I told you in the Bootstrap configuration, you are configuring only the vBond IP, nothing else. So by this, when a Vantage device is activated or when you restart it, it makes a contact with vBond. And vBond is going to perform authorization. How I'm coming up, we have a last part theoretically to discuss device bring up. Step by step, which device comes in first, next who comes in, how they connect. That step-by-step process I'm going to explain. At that time, few things I'll put it across how vBond is going to authenticate this guy. As of now, let's keep it simple. You contact vBond. vBond already knows about you. He knows about your details. He's expecting you. So as you make a contact, he is going to authenticate saying, okay, you are the right guy. And if that is the case, I will tell you who's the vManage and who's the vSmart. You contact them and they will be responsible for their jobs like vManage. Once you contact vManage, you are going to make a next contact with vManage. He's going to give you all the configurations you need. He may perform software upgrade if necessary. If there was any software upgrade available, he may perform a software upgrade to you. And he's responsible to give you a certificate as well. We'll talk more about it. Next upcoming theory session, we are going to discuss about that as well. It will give you a certificate as well. So vManage gives you all these things and then you are ready to make a contact with vSmart. And when you make a contact with vSmart, all that OMPs, all those logics will come up and you're ready. So vBond is the one who begins the story. Plus on your topology, on your SD-WAN, you are adding a new vSmart, let's say, for example. A new vSmart has been added. You have to inform this to all the Vantage devices so that they can make a contact and they can establish an OMP and make a redundancy resilience. So here in this case, when you add a vSmart, you have to inform this to the vBond. So vBond gets updated and vBond immediately will update the Vantage. There's a new vSmart available. You can make a contact and you can create an OMP and go ahead. So vBond comes into the picture during these cases. Once the contact is made with vManage, vSmart, vBond is not necessary. But that doesn't mean you turn it off. Because we don't know, new vSmart can come, vSmart can fail. So things can change. So a vBond is necessary there to do this orchestration. So that's the vBond which comes up here. Any question, anything on vBond? All right. A vBond is not a dedicated image or a controller. It's a controller, but it doesn't have a dedicated image. It is the VH Cloud which we install it and convert it. We install one Vantage device, one VH Cloud device, and then we change the role of the device so that it can perform the job of vBond. So when you go to Cisco and try downloading the image, you get the image for vManage, you get an image for vSmart, and you get the image for VH or CSR router, iOS XE, etc. So one of this Vantage device, VH Cloud, when we install, we convert him into vBond as just a single line command. He gets converted to vBond and he does this job. So remember, it's not a separate image or a separate kind of controller. It is basically a Vantage device doing this extra service for us. But a vBond, never a service plane should be used. Service VPN will not be allowed on it. Once you make him as a vBond, you'll have control plane, management plane, VPN 0, VPN 512. That's it. Any question, anything? This is SD-WAN architecture. Few more things probably in tomorrow's class. Device bring up, how you get the license file or the serial file, and how the certificates are managed. Few things we will discuss. And we will do from scratch SD-WAN configuration right from installation. We will install vManage, vSmart. It will take little time, installation and all. We have to be a little patient in seeing the installation. Then I have to log in, takes little time. So that part, installation part, will be little prolonged. So we'll see from scratch all that, how to install, how to get connected. Then we'll bring up some policies, routing policies, and we'll see how to work on them. For today's session, I'm going to stop here. If you have any questions, then let me know. If not, we are going to wind up here. Yes, no questions. So I'll wind up. So I'll see you all in tomorrow's class. We will continue. See you all then.
John,
Bye. Yes.
John, if possible, can you share the images to EVNG? I need to set up.
EVNG. Sorry, I didn't get you. What image you want? A vManage image, or you want?
vManage, vBond, and vSmart, and
Okay. Sure. I
maybe
will send you.
Edge router image.
Yes. That I'll send it across. Sure.
Okay, John. Thank you.
Welcome. Okay. See you all then. Bye.
Thank you, Bonnie.
Welcome.